I want to do is I want to make some notes for you. All right. So the end behavior, what they're talking about is as X gets big, Y is doing what? All right. So if I was looking at this graph, all right, let's make this my X and Y axis. All right, and again, this is just the graph of Y equals X. All right, if that's the graph of Y equals X, as X is getting bigger, what is Y doing? It is getting bigger. All right, so we say the end behavior as X gets big, Y is getting big. All right. It's not in those terms. I'll explain the better terms in a minute. Then we say as X gets what? Small, Y gets what? Y gets small. All right. So the answer is always, what is Y doing? All right. The answer is always, what is Y doing? Now, eventually, all right, just listen to the notation. It will be something like this. What's the limit as X approaches infinity? So the question is, again, what is Y doing? All right, it's going to infinity. All right, and we say the limit as X approaches negative infinity is negative infinity. All right, now what does that mean about the end behavior? The end behavior is showing you that it's going up and it's going what? Down. All right. Now, again, very, very simple. All right. As X gets bigger, Y is getting bigger. As X gets smaller, Y is getting smaller. All right. But if you look at the notation seems kind of complicated. All right. So now the next is Y equals what? Good. X squared. All right, because 2x is the same as what? X. All right. So if I say Y equals X squared, of course, everybody in here knows the general shape for Y equals X squared. Thank you. It is a parabola. So we say as X approaches infinity, Y approaches what? What?
Square root.
No, I'm asking you a question. As X gets bigger, what does Y do? Man, I'm doing a horrible job. So if I say X is 1, what's Y? If I say X is 2, what's Y? If I say when X is 3. So as X gets bigger, Y gets bigger. Right? That's all that means. All right. And I'm always confused about why that is so difficult. All right. Even if you're looking at the graph, again, as X heads in this direction, Y is heading in what direction? Up. And up stands for infinity. The bigger X gets, the bigger Y gets. So we say as X approaches infinity, Y approaches what? Infinity. As X approaches negative infinity, what? Y approaches infinity. Okay, now we're making progress. Now we're making progress. All right. So now Y equals X cubed. All right. So now a lot of times kids say, well, you never showed me how to graph Y equals X cubed. You're right. So what is 0 cubed? 0. What is 1 cubed? What is 2 cubed? 8. So as X gets bigger, Y is approaching what? Infinity. Now plug -1 in. When you get plug -1, you get what? -1. When you get -2, -8. So was there really anything difficult about graphing x cubed? No. X cubed looks like this. So we say as x approaches -infinity, y is approaching what? -infinity. That's how simple. All right. Now let's get wild and crazy. Let's say I ask you about y equals x to the 4th. What do you think y equals x to the 4th looks like? It looks exactly like y equals x squared. All right, except it's increasing, bless you, at a faster rate. Why is that? Because what's 1 to the 4th? 1, but what's 2 to the 4th? Instead of 4. All right, so everybody should be able to look at y equals x to the 4th. All right, when you're graphing it, all right, you should understand that it just is more narrow and it looks exactly like x squared. So we say as x approaches infinity, y approaches what? Infinity. As x approaches -infinity, y approaches infinity. Beautiful. Again, because, and some of my kids are like, how do you remember all that? It has nothing to do with remembering. A negative to an even power is what? Positive. A positive to an even power is what? There you have it. That's how simple it is. If I say something like x to the 5th, everybody should be able to tell me without looking what the graph is. X approaches infinity, y is approaching what? If x approaches -infinity, y approaches, yay, now you understand. All right, it's really that simple. All right, again, the notation looks a little bit more complicated. And you would say x to the 5th looks very much like what? X to the 3rd, because if you cube a positive, you get a what? Positive. If you cube, or if you raise something to a positive to the 5th power, you get a positive. And the same thing with negative. If you cube a negative, you get a negative. If you raise a negative to a 5th power, it's still negative. All right, so again, there's not much to memorize here. All right, now if you wanted to, you could just type in on your calculator, y equals x, y equals x squared, y equals x cubed, y equals x to the 4th, y equals x to the 5th on 5 graphs, and just look at it and see exactly what I'm talking about. All right. And those are called the parent functions, the most basic form. All right, that's the most basic form. All right, does anybody have any questions with that? All right, so the end behavior is just what's the graph doing as x gets big and as x gets small. All right. All right, now let's look at question number 2. Is the first one a polynomial function? Yes. Yes, this is yes. Again, if you'll notice, all of the exponents are whole numbers. What about g of x? Is that a polynomial? Yes. Yes. The 3/4 has nothing to do with the exponent. What about h? Is that? No. No, because it says x to the what? It has x to the -1. That's how simple. So h is not considered a polynomial. What about k? Yes, it is a polynomial because all of the exponents are whole numbers. All the x numbers are, or all the exponents are whole numbers. Anybody have any questions? All right. Now, this is something I feel like everybody should know. Writing in standard form. First of all, decide if it is a polynomial. Is 3 a polynomial? Is it written in standard form? No. It's not written in standard form because why? The exponents are not in descending order. So to write it in standard form, we're just going to write f of x equals 5x cubed minus 6x squared minus 3x plus 2. That would be standard form. Anybody have any issues with that? All right, now, just to make sure, let's look at number 4. Let's rewrite it. P of x is equal to what? Yeah, I told you guys, simple, simple, simple. Oh yeah, I didn't say that. I didn't even read that. Thank you. All right. So yes, the degree. What's the degree for number 3? 3. Yeah. All right. I'm glad you guys remember that. And what's the degree for number 4? 4. All right. Now the leading coefficient. The leading coefficient for number 3 is what? 5. And the leading coefficient for number 4? 6. All right. So I'm good with all that. All right. You remember, it's been a long time since we've done out of a book, but I just never like the errors. Who cares? All right. So you don't have to do 9 and 10. All right. Now let's look over at number 11. All right. Evaluate the function for the given value of x. So again, we're not really going to use a calculator because we're going to practice our mental math here. All right. So basically what we're doing is we're saying what's h of -2. Now I don't care about the other ones, but I care about this one because I'm trying to refresh your memory on powers. All right. And what to do if it's positive or negative. All right. So -2 to the 4th. What is that? 16 times -3. All right. Then we're plugging -2 in here. And that would be what? -16 also. Thank you. And then plug -2 in for this x. Plus 24. And then what? -6. All right. So it looks to me like h of -2 is equal to negative. Whoa. I did not get that. I got -46. Anybody else get that? All right. I think it's -46. All right. That's why we're practicing our mental math. All right. On that. All right. But I don't really care about, -7 to the 4th power. I really don't care about that. I don't mind using your calculator. But I would like to say this, though, guys. To save yourself a heartache, if you do -7 to the 4th power on your calculators, I can give you the right answer or the wrong answer. It's going to give you the wrong answer. Why is that? Yeah, it has to be in parentheses. Thank you, Bo. It must be in parentheses. So now I want everybody to listen to me. If I'm doing -7 to the 4th power and putting parentheses, I was always smart enough to realize, well, if I want to do it the quickest possible way, would I really have to worry about the parentheses if I just made it what? 7. Does everybody understand what I'm saying? If you're going to raise an odd number to an even power, there was no reason to put in the what? And now I don't have to put in the what? Parentheses, right? If it was -7 to the 3rd power, would I need to put parentheses in? Would I need to put parentheses in if I was doing -7 to the 3rd power? No, I would not, because the answer is automatically going to come up to be what? Negative anyway. Is everybody with me on that? All right, but a lot of times as I'm doing these, I'm determining the outcome, whether it's positive or negative, as to if I'm going to plug the number in. All right, so let's everybody go ahead and do number 12. And I really don't care if you use your calculator, all right, but h of -7. But just do me a favor. You do the work, all right? I don't want someone to tell me the answer and then you just put the answer down. All right, I want you to do the work. Somebody tell me. Is that? Double check him.
1,690.
What was that? Zayden, tell me that again, please.
16,193.
16,193. Somebody else.
Yeah, 16,193.
I got 16,193.
All right.
Brady.
Brady is terrible today.
Brady's always wrong.
3 in a row.
Oh from May, Brady. Really good start. Shh, shh, shh. All right. Anybody else? Okay. Now, all right, we have something new. All right, let me try to teach you something new now. I want everybody to look up. All right, we're going to describe the end behavior. All right. First of all, right, everybody look up, because I'm trying to now teach you how to be better at understanding math. All right, math seems complicated. All right, it's complicated if you don't understand what I'm saying. So now is the time to listen. All right, make sure you understand what I'm saying. All right. Now, again, as X gets big, all right, and I'm on number 17. All right, as X gets big, does the +2 really affect the outcome? No. If I'm at 1 billion and I add 2, does it really matter? Right. It's kind of like I used to tell kids, if you think about like Bill Gates' bank account, and if you put $5 in his bank account, it's probably not even going to show up. All right. When you're talking about billions of dollars, or the government is spending trillions of dollars, what's another $5? All right. We say that that's insignificant. All right. We say it's insignificant. So if I put infinity in for X, is that going to make a difference?
Yes.
All right. So now if you think it's going to make a difference, compare that if I plug in infinity to the 4th power. We say that infinity to the 4th power is so much greater than just infinity that this 9x is also insignificant. All right. And the same principle for what? Square. Think about if you do 1,000 and you square 1,000 and then you raise 1,000 to the 4th power. 1,000 to the 4th is way bigger than what? 1,000 squared. All right. And you just compound that by making the number even larger. You don't even have to think about 1,000. You thought about 1,000,000 or 1 billion or 1 trillion. All right. The numbers become so big, so fast that we say that these numbers here are insignificant. So the only thing that is important is the degree and the leading coefficient. All right. So I want somebody to tell me who's thinking, if I said as X gets big, because these are called insignificant, what is Y doing? Now, before you say something, look up there on the board and think about it. Don't just guess. All right. Now, as X gets big, what is Y doing? Who said that? Who? Y. Yes, exactly. So again, I never understood what was difficult about this concept. If I put a negative number in here for X and raise it to the 4th power, it becomes what? But then I multiply it by a negative. So that means as X goes to infinity, Y goes to what? Negative infinity, which just basically means the graph is going down. The next statement would be, as X approaches negative infinity, then Y is approaching. Now remember, you're not supposed to just say something. It's not what you think. Look up the board and tell me what you know is true. I said, as X gets bigger, what is Y doing? Getting what, Ruffin? Why? Because of the -5 again. Exactly. If you raise a positive number to the 4th power, you get a positive. But then there's a negative that does what? Makes it negative. All right, that's how simple this is. And like I said, I never can understand why that's a difficult concept. Now, most of the time it's difficult for most kids because they don't understand what I'm telling you about this information right here. All of this information is considered what? Insignificant. X is so large that if I raise it to the 4th power and raise it to the 3rd power, this overpowers everything else. So it's like it doesn't even exist. It doesn't even matter. All right. So we would say the end behavior is -infinity and -infinity. So if you were to graph that, all right, and this is what you'll be studying a lot, graphs. All right. As you graph that, I know that it's going to look something like this. All right. I absolutely know it's going to look something like that. All right. Now, if you want to type that in, you're welcome to, but trust me. All right. That is kind of what it looks like. All right. So now, just to make sure I'm in good shape. All right. We're going to talk about number 18. So I want, as X approaches infinity, Y, besides Ruffin, Y is approaching what? Why is that?
Because the 7 is positive.
Yes. As I plug in a number positive, raising it to the 7th power still is what? Positive. Multiplying it by a positive is still what? So we say Y is going to infinity. Now we say as X goes to -infinity, then Y is going to where? Yay, now you guys are awesome. -infinity. All right, so what does that mean? If I were to actually physically look at the graph, all right, it would look something like this. All right, and eventually you'll just be able to graph that. All right, when you get a little wiser. Yes.
Why do you do, X negative infinity and Y negative infinity instead of X to infinity and Y to infinity?
Look, there's 2, right? Do you see this?
Yeah.
As X gets big, Y gets big. As X gets small, Y gets small. Right? So in other words, as X heads in this direction, Y ends up going what? Down. Now, again, I want everybody try to listen now because I'm really trying to help you for next year. Listen, does it always go down if you're going to the left? No, it's only going to go down as you keep getting what? Larger, or I should say more negative. You with me on that? So again, if I was graphing something, all right, you can be going up and down, but as I get bigger and bigger, it's going to ultimately just keep going what? It's going down. Do you understand what I'm saying? As I'm going to the right, it's going up and down, but at some point, it's just going to always be going what? Does that understand? All right. And also, if we were to just graph X to the 7th, it would take on those characteristics eventually. It's just there's a lot going on here in the middle of the graph that you're going to learn how to figure out what's going on when you get a little bit more advanced. All right. So here we go. Let's see if I taught you anything. Now you're looking at the graph of number 21. Can someone tell me if it's an odd degree or an even degree? Why is it odd?
I think from the X is negative, the Y is positive.
Now let's look up here. Just to refresh, I've failed to mention that. Look at all of the evens. The evens are both going what? Up, or they will both be going what? Whereas if you look at the odds, one goes up and one goes what? Now, again, you're not supposed to memorize that. You're supposed to say that's just common sense. If I put a positive number in, I get a positive when it's odd. And when I put a negative in, I get a what? Negative if it's odd. All right, so there's no reason to memorize that. To me, that's just understanding numbers. So if I'm looking at this problem right here, I can say this is what? Odd. Now, normally, when you plug in a positive, you get a what? But now I'm getting a what? So that means the leading coefficient must be what? Must be negative. All right. So here it is an odd degree and the leading coefficient is negative. All right. So let's look at 22. Bless you. So for 22, what am I saying? It is definitely even. And the leading coefficient is what? All right. I hope everybody's just like, this is just so simple now, right? Tell me though.
I don't think I would ever use that. How do you know whether the coefficients, positive or negative?
Okay, because if this is an even, that makes it x to the fourth or x to the sixth or to eighth or 10th. I could even say squared, but it's got to be one of those. Do you agree with that?
Yeah.
So if it's one of those, and when I plug in a positive number, I get a what? I get a positive number. You with me? If I put negative number in, I get a what? Positive. Therefore, the leading coefficient must be positive. Because if the leading coefficient was negative, it would look going down. Because when you raise a number to an even power, it's going to be positive. Therefore, it's got to go up. Does that make any sense? And you can say no, kiddo.
That would make sense. What about the other one?
So over here, if it's odd, it would be something like x cubed or x to the fifth or x to the seventh, right? So if I plug in a positive number, what's my y value? My y value is negative. So the only way to plug in a positive and get a negative is if it's negative x to like 7. Does that make sense? Because a positive number to the 7th power is positive, but then negative. Good? All right. So that was the hard part. Yes, sir. Good for you.
What if we were to like, let's say we flip number 21. Like, you know what I mean?
Yeah, I do know what you
Would that make it the
leading coefficient is a.
is positive?
That is
and
correct.
the other-
If it went like that, the leading coefficient would be positive.
And that would make the exponent even.
No, exponent is still odd because they're going in opposite directions.
Oh.
Now, again, I'm trying to get you to understand the reason why I know it's odd is because if I plug in a positive, I get a what? Positive. If I plug in a negative, I'm getting a what? That's how you tell. I know it's even because if I plug in a positive, I get a positive. If I plug in a negative, I get a positive. Right? All right. Super easy. All right. Super easy. All right. But that's what we talk about when you get to higher level math. You have to understand. No memorizing. All right. Now let's go back to the easy part. I don't know if I'm going to even spend time with you on this. All right. Well, I should just to make sure. All right. Number 3. We're just doing what? Adding them. Someone tell me. X squared plus x plus 1. All right. All we're doing is what? Yeah, it's hard to believe. We're just combining like terms. That's it. Anybody have any issues with the addition?
No.
All right. So here we go. Let's go with the subtraction now. Let's just do one real quick. Now, I always remind kids that we're distributing a what? A negative. So in my opinion, what I used to do is make the kids do this. All right. Each time I would put something and I would circle that I've changed all the signs, because honestly, the mistakes come when you make an error with the negatives. All right. Yes, sir. Tell
Can
me.
you subtract it?
Yeah, I don't mind, but I'm just telling you from experience, you end up at the end forgetting to subtract. Right. And it makes no difference to me. You have to decide what's best for you on this. I'm just showing you, I never wanted to make a mistake, and I made mistakes with what? Negatives. So I do everything I can to avoid the negatives. All right. So that's why I just change positive and then change the signs. And then I just treat it just like the addition. All right. So now we know the final answer is. All right. Simple, simple. I'm agreeing. Simple. Nothing to it. All right. So we just reviewed addition. We just reviewed subtraction. I don't care about that. 15 is no good. All right. Let's look over here. 16. I don't care about modeling. All right. Here we go. Now, okay. So finally, all right. Let's go ahead and do 17. Final answer.
5x to the fifth plus 21x to the fourth plus 7x cubed.
All right. So that one's easy. All right. So now I know 18 is easy. All right. Now, is 19 a pain? Yeah. Is 21 a pain? Yeah. 21 is really annoying. And what about 23? Yeah. Really annoying. All right. So I'm of the opinion, if I can do 23, then you can do the rest of them. All right. So what we're going to do is we're going to review how to do 23. All right. Now, if you recall, I taught you last year to kind of stack them on top of each other. All right. But this year, I think you're a little wiser. All right. So that's not really necessary. I taught that to you last year just because it helped you organize things. All right. So now everyone should be able to just say, I'm really just distributing the 3x cubed. Does everybody agree with this? All right. So now just watch, right, and see how organizing is helpful. All right. I don't want to stack them on top of each other. All right. You should be good at the mental math. So here we go. You're going to write down 3x to the fifth minus 6x to the fourth plus 3x cubed. Is everybody okay with that? Now what? I'm going to the 9x and I get negative 9x cubed. Does everybody agree? Now, I'm not going to put negative 9x cubed here because then it just gets long and strung out. All right. I'm going to put negative 9x cubed right under the negative 9x or the 3x cubed because that's where it goes. That way I know I'm just combining those terms. Then I just get positive 18x squared and then negative 9x. And now I'm distributing the 7. That becomes positive 7x squared minus 14x plus 7. Is everybody okay with that? And now, of course, you're just adding 3x to the fifth minus 6x to the fourth minus 6x cubed plus 25x squared minus 23x plus 7. That did not take me that much time. All right. It really didn't. All right. Does everybody understand what we did there? Anybody have any questions? All right. You don't want to stack it on top of each other. If you learn this little procedure right here, I just think it's just very simple. Anybody have any questions? All right. So we have 15 minutes, guys. Listen. Again, remember what I'm telling you. I'm trying to help you. All right. So what I want to do is let's do section 4-1. Let's go ahead and 7, 13, 15, 19, 20. Is everybody writing those down? Highlight them, please. 7, 13, 15, 19, 20. And then on the next lesson, let's do 5, 7, 11, 13, 19, 21, 23. What did you say? Just come on, Harris. Be a big boy. Don't let them bully you. What did you say?
We did number three.
Peer pressure.
Yes, if we did number three.
I already did number 3. What's the problem, guys? I should make you do all of them just because of your reaction. Boys, not the girls. Girls are always good. Right, girls? Yeah, right, whatever. Okay, so that's good enough. All right, then tomorrow we'll just continue on down the page. All right, so you got 15 minutes or less than that now, but get that done. All right, get it done. All right, if you weren't sure about my in behavior stuff, you can let me know. We can talk about it. Oh, hey, Sam. Did you get everything?
Yeah, I got
All right, man. We'll hopefully see you back soon, man.
yeah, he'll be there tomorrow.
All right.
You gotta turn on your camera.
Sam, turn on your camera. Turn on your camera.
Oh, he left you.
Or he heard your voice.